Okay, we're going on to section 5 of chapter 7. This topic isn't included in the curriculum, but is really a bridge from material we've covered to material we will cover. And I'll try to keep it short and some good stuff here. So let's go on. Now, when we are adding radicals, what we add similar to what we've done in other areas of algebra, like terms, but now they're calling them like radicals. And we'll illustrate what that is here. So if the radical part is identical, these are considered like radicals. And the rule is we just add the numerical coefficient of the radical, which in this case is 3, and 7. So this will give us 10, the square root of 5. So the radical part stays the same. Here we're just adding the numerical coefficient of it. Now here, these are like radicals. So, and keep in mind there's a 1 in front of this. So this is 7 plus 1 is 8. Minus 2 gives you 6. And then you write this part. All right, let's see it in action here. So again, in a sense, you're factoring out the 5, and then you're adding the 3 and 7. And again, you're factoring out the radical part in a sense. You do this mentally, and there we get our answer. And some more here. And you might say, well, wait a minute, these aren't like radicals. Well, that's true. Not yet. But let's do a lesson we had earlier. So we said that 2, the square root of 18, can be converted to 9 times the square root of 2 minus 7, the square root of 2. Well, over here now, what is the square root of 9? Well, 3. So this comes out as a 3. So this will be 6, the square root of 2, minus 7, the square root of 2, which then we just deal with our numerical coefficients, is a negative square root of 2. There's a 1 there, we don't write it. So here we have 10, the cube root of 3m, plus the cube root. Now watch what I'm going to do here. This is going to be 8 times 3. Oh, they may have made a little error here. And m to the third. Let's do it this way and see what happens. So this is going to be 10, the cube root of 3m. And then this becomes, now 8 is a perfect cube, so that comes out as a 2. M is a perfect cube, so it comes out as an m. And we have the third root of 3. Well, these are not like terms. I have a feeling maybe they shouldn't have put that there, then it would have been like terms. Let's see how they do it. So they, again, tease out the 9 as a factor of 18, which is a perfect square. We did that in an earlier lesson, and there's how they get the answer, and that's what we did too. Notice as they did this, Yeah, there's an error here. Now, if this were m to the fourth, that would have been okay. But again, there's an error here. The way I had it before was okay. If this were to the fourth, then it would have looked like that. Okay, so there's a little error there. I'll have to call the company. Okay, products and quotients of two or more radical terms. This gives you some methods for dealing with some of these things, as we'll see. Now here they're asking us to do some multiplication. So we're going to distribute that, and this becomes y, the square root of 2. That's just multiplying these two terms. And now the square root of 2 times the square root of 7 gives me the square root of 14. Now in this case, we're multiplying, in a sense, a binomial by a binomial. We're going to FOIL. Okay? So watch this. We're going to multiply this one by this one and get the third root of x cubed, which I know is just going to be x. Then we're going to do our outers, and we get negative 3, the cube root of x. Now my inners, and we get plus 2, the cube root of x squared. And then we do our last, which is going to be a negative 6. Now, you might leave it this way, but I don't think it's a good idea not to simplify this. So this will be just plain x, and then the rest of this stays the same. You can't combine these because they're not like terms. Now, as we look at letter C, something interesting is happening. Here we see these radicals are the same. One has a plus, one has a minus. These are actually conjugates. And we saw conjugates back in chapter 5 when we had this, a plus b, a minus b, that when we FOIL them, they gave us the difference of perfect squares. That is, the middle terms subtract out. So that's going to happen here. So here's what we're going to get. We're going to get the square root of m squared minus the square root of n squared. But what is the square root of m squared? Well, it's m, and this is going to be minus n. So it's very similar to this, but it's that. And keep in mind now, later in some future course, if you have to factor this, it will factor into that. But right now we're not going that direction. So there's the first one they're showing you, and then there's the answer. Notice the protocol for writing these is you put the y in front of the radical sign. And here we're foiling, and they're just showing you the FOIL. And you get 3, the cube root of 3 cubed, or the third root of 3 cubed, which is going to be 3. These are not like terms. So the only change you can make in that next step was to take the cube root of this to get the x. Now, when we FOIL, again, conjugates, notice that the outers and the inners are going to cancel out. And we get that. Okay. Now here they're reviewing what we just reviewed, indicating that these are conjugates. When you multiply conjugates, the middle terms cancel out. It's a good tool that we're going to use in our next little part. And that's rationalizing denominators and numerators with two terms. Now we did it with one term, but there'll be some with two terms. So to rationalize this, we are going to look at our denominator and say, well, what's the conjugate of this? Well, the conjugate of this would be the same terms, but opposite sign. So this was plus, this is going to be minus. Now, what do we have in red? This over this. This is actually a 1. This equals a 1. We are allowed to multiply anything by 1 and not change its value. So that's what we're doing here. But notice, when we do this, this becomes the square root of 49, which is 7, and then minus y squared as we FOIL our bottom. Now our top will be 5, the square root of 7, minus 5y. Notice we had a radical in the denominator. We have rationalized the denominator by multiplying a two-term denominator by its conjugate right here. Okay. Again, the setup of it, and then finally when it's FOILed. And keep in mind, when you have a radical times a radical, it just becomes the radicand. Or you can take it to 49. Square root of 49 is 7. Okay, let's rationalize this one. So we start off by putting a parenthesis around it. And what is the conjugate of that? Well, it will be the same items, terms, I guess, opposite sign. Now, notice this is just 1. So let's just do it down here. Square root of 7, square root of 7, square root of 49 just becomes 7. This is going to become a negative square root of 9, which is 3. So our denominator here is going to be a 4. And now we'll FOIL the top here. So this is going to be, I'll put it down here because I don't think you can do anything with it. 5, the square root of 7, that's my first. My outers and my inners, yes, they're going to be distinct radicals. So this is going to be plus 5, the square root of 3. That's my outers. My inners is plus the square root of 21. That's the square root of 7 times the square root of 3. And then my last, square root of 3 times square root of 3, square root of 9. And that gives me a 3. Now all of that will be over by 4. Where did I get the 4 from? By FOILing these conjugates. 7 minus 3 is 4. There are no like terms on top, so that is it. Okay, 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 and there is our answer. We're going to have one more step here. We have to get a 4 there somewhere, over here. All right, there we go. Went too fast, right over here. Now, to rationalize the numerator, again, it's the very same thing. But this time we use the conjugate of the numerator. And you may want to try some of these too. They're kind of fun, actually. So it's the same terms, but opposite sign. So as we do our numerator, this is going to be 25 minus 3, which our numerator then will become 22. And now we do our bottom. So this is going to be 5, the square root of 7. Outers are a negative square root of 21. This one times this one. Inners, a negative 5, the square root of 3. And then my last is minus times minus is a negative, times negative will be a positive 9. Okay, so it never hurts to check your work. Let's see, 5, the square root of 7, negative 21, negative 5, square root of 3. This becomes a square root of 9, positive. Oh, yeah, I did have an error there. It's supposed to be a 3. I think I said 3. I don't know why I wrote 9 here. Okay, got it. Check your work. And there we go. Now, here's something that ties in with section 2, which usually is taught in this chapter, but pause it if you want to read it over. I'm going to show it to you here. Okay, it says multiply and if possible, simplify. So here what we're going to do is convert this to x to the 1/2 power, that's this one, times x to the 3/5 power. I'm converting it from its radical form into its fractional exponent form. Okay? Where this is the denominator, this is the numerator of our exponent. So if we wanted to multiply these, we have to have common denominators, which will be 10. So this one's going to be 5/10. I'm not going into how to do fractions. You should know that by now. And this is 6. So this will then become x to the 11/10 power. So I'm not sure if they want it like this or in radical form. If they want it in radical form, remember this is going to be x 10 over 10, which is just plain x, times x to the 1/10. So this would then become x and then the 10th root of x. Again, let's see how they want to do this. Okay, so far. And that, is that how they're going to leave it? No. Well, I hope they simplify it. And again, this one here is just plain x. And this is the 10th. Okay, that looks good. Good. All right, they made that 10 big. I guess they had trouble printing it small. Okay. Now we're going to do some division. Let me set this up. So just converting this into its fractional form, this becomes a to the 2/3, b to the 4/3 over a to 1/2, b to 1/2. I'm then going to bring this up and subtract it from that, bring that up and subtract it from that. But in order to do subtracting, I need to have common denominators. So here this is going to be 4/6, and this will be 3/6, and this is going to be 8/6, and this is going to be 3/6. Okay, now I can subtract them. So this becomes a to the 1/6, and this becomes b to the 5/6. So converting that back into its radical form, it'll be the 6th root of a, b to the 5th. Okay, that was an interesting one, not too difficult, but a little bit challenging. Again, we converted it to its fractional form. We did our division by subtraction. We had to have common denominators. And then when we did our subtraction, we converted it back into its radical form. And again, I don't like their putting the fractions like that, but that's the way they're doing it. And they're getting common denominators. And then the final step is what we had. Okay? And that completes this.